Hello everyone, welcome to week 3 question review session. So again, the quizzes and the exam questions will be multiple choices or true or false questions, but here I directly giving out the answer just for simplicity purposes. Okay, so yeah, let's get started. So let's first check the key point of this 2 chapters we studied this week. So again, the most important thing you need to understand is about this diagram, okay? How this diagram clearly will tell you how we convert the mole of the substance into the number of atoms or number of molecule and, and into the mass of the substance. Okay? And also, you need to know how to balance the chemical equation and the typical observations of chemical reactions and the solubility of different substances. So now let's see some example questions, okay, for this week. The first question is asking you how many atoms are there in 2.6 mole of oxygen gas and C60. Okay, so how do we solve this question? So again, based on the diagram, I just show you in order to convert the mole into the number of the atoms or number of the molecules, we need to multiply by the Avogadro number, right? So in terms of the oxygen, 2.6 moles of the oxygen molecule will give us 5.2 mole of oxygen atom, right? So how do we convert 5.2 moles of the oxygen atom into the exact number? We multiply by Avogadro number. So 5.2 times 6.022 times 10 to the power of 23 will give us an answer. Next one, the C60. Okay, this is a bizarre molecule. Probably it is the first time you see this, but don't worry. As long as we understand what does the 60 mean, we should be able to solve the question. So what does the 60 mean? 60 means in one molecule, there are 60 atoms, right? So if we have 6.2.6 moles of the molecule, how many atoms are there in this amount of the molecule? We multiply by 60, right? It's same as what we do here, we multiply by 2. So after we multiply by 60, we will get how much? 156 mole of the carbon atom. And then the next thing is we need to convert this amount of the carbon atom into exact amount. So we times the Avogadro number, which is 6.022 times 10 to the power of 23. Right? Yeah, so this is the first question. Second question, it is asking you 2 moles of the oxygen and 2 moles of the aluminum has a mass of. So in this case, when we try to convert the mole into the mass, we need to go to our best friend, which is our periodic table, and find out the molecular mass or the atomic mass, right? So the first one, oxygen. Oxygen we need to find out is molecular mass. So again, we first go to our periodic table and see, okay, this is oxygen. Oxygen is 16 for one oxygen atom, but for the oxygen molecule, there are 2 oxygen atoms. Therefore, the molecular mass for O2 will be 16 multiplied by 2 will be 32 gram per mole. Okay, so now we have 2 moles of the oxygen, so the result will be 64 gram. Aluminum is a bit simple because we just need to read the atomic mass for the aluminum, right? Aluminum is 26.98. So 26.98 times 2 will give us the result. Okay. The third question, how many mole are there in 17.5 gram of iron? In this case, we are doing the calculation in a reverse way. In order to calculate the mole from the mass, we need to use the mass divided by the atomic mass or molecular mass, right? For the iron, still we read from the periodic table, it is 55.85. So in this case, we just need to use 17.5 divided by 50.85, and that will give us the answer. Okay, next question. How many moles of the copper are there in this amount of the copper atoms? So in order to calculate the mole from the exact number of something, we need to divide it by the Avogadro number. So we need to use 1.48 times 10 to the power 25 minus divided by 60.22 times 10 to the 23rd. And that will give us the answer. Okay. Next question. What is the mass of this amount of the argon in gram? So again, so in order to calculate the mass from the exact number, there's no direct way. We need to calculate it into two steps. The first step is convert it into mole, and second step is convert it into mass. In order to convert it into mole, we just need to use 3.09 times 10 to the 24 divided by the Avogadro number. And then we multiply by the molecular mass of the argon. The molecular mass of the argon can be directly read from the periodic table, which is 39.95. Okay, that will give us the answer of 205 grams. Okay, next question. The mass of 1 mole of carbon dioxide is the mass of 1 mole of carbon dioxide. So again, this is a question asking you to convert the number of mole into the mass. We need to rely on our periodic table and find out the molecular mass of the carbon dioxide. For the carbon dioxide, it has 1 carbon, which gives us the molecular atomic mass of 12, right? It has 2 oxygen. For 1 oxygen, its molecular mass, its atomic mass is 16. So we use 16 times 2. This will give us 44 gram per mole. So in this case, the mass of 1 mole of the carbon dioxide will be 44 or 44.01 if you want to be precise. Okay. Next question. So for 1 mole of the potassium sulfate, it contains what? 1 mole of the potassium sulfate, it will contain, let's check the subscript of each element. So this 2 means it contains 2 sodium. The sulfur, it means there's only 1 sulfur. And for the oxygen, there are 4 oxygen. Therefore, it means for 1 mole of the sodium sulfate, it will contain 2 moles of the sodium, 1 mole of sulfur, and 4 mole of oxygen. The last question about the chapter 5. What is the mass percent of bromine in hydrobromic acid? In order to calculate this, we need to understand what is the definition of mass percent of something. Mass percent of an element can be calculated as the mass of the element divided by the mass of the compound, right? So what is the mass of the element in this HBr? For the bromine, we need to read the atomic mass of the bromine, right? So we go to the periodic table and find out, okay, the bromine, the mass is 79.9 gram. So 79.9 gram divided by the mass of the compound. What is the mass of the compound? Hydrogen plus the bromine. Hydrogen mass is 1, and the mass of the bromine again is 79.9. So that will give us the answer, which will be about 98.7%. Okay, that's about this chapter we learned. Let's then check the questions about the next chapter. The first question is asking you to list the evidence that a chemical reaction has occurred. This is something we discussed, right? There are 5 evidence that can indicate there's a high chance that there's a chemical reaction. The 5 evidence include the first one, emission of the light; second one, emission of the heat; third one, the color change; the fourth one, generation of the gas; the last one, the generation of the precipitate or generation of the solid. Okay, next question. Write the coefficient of the following questions. Oh, so this chemical equations has been balanced, but we still can do some practice. Okay, for the first one, oxygen react. First, we write the skeleton chemical equation. Okay, oxygen react with hydrogen to generate water. So in this case, it is definitely not balanced yet. So in order to balance, because here we have two, because here we have, oh, let me change the color. Here we have 2 oxygen on the left side. We only have 1 oxygen on the right side. That is why we need to add the 2 here. But after we add 2, we have 4 hydrogen on our right side. So in order to balance it on the left side, we want to also add a 2 here. That is how we balance the first equation. Second one, the skeleton equation is chromium react with HCl will give us a chromium chloride and some hydrogen gas. So in this case, if we want to balance it, first we just check chlorine. Okay, chlorine in left side on the left side there are 1, but on the right side there are 3. So we give it a 3 here. And now the chlorine is balanced. What about the hydrogen? Hydrogen now on the left side we have 3, but on the right side we have 2. So how do we balance this? We give it 1.5. Okay, we give it 1.5. And this is about this is a balanced chemical equation. Okay, the coefficient is 1, 3, 1, 1.5. But although it is balanced, but based on the convention, we want to avoid like just 1.5. So in order to avoid this, we give it another coefficient, which by multiply 2 on everything. Okay, so after we multiply by 2, the final coefficient will be 2, 6, 2, and 3. Okay, this is how we balance the second chemical equation. And the third one, calcium nitrate react with water will give you what we call the calcium hydroxide and ammonia. Okay, this is the skeleton. Again, this is skeleton. How do we balance it? Same thing, we're applying the same strategy. On the left side, we have 3 calcium. On the right side, we only have 1. That is why we multiply by 3 here. Okay. And on the left side, we have 2 nitrogen. And on the right side, we only have 1. So we also added 2 coefficient in front of the ammonia. Now let's check what are the rest of the elements that are not balanced. Calcium is balanced. Nitrogen are balanced. What about the hydrogen? Is hydrogen balanced? Apparently not. So on the left side, we have 6 times 3, we got 6 hydrogen here, and here we also get 6 hydrogen here. So in total, we have 12 hydrogen. But on the left side, we only have 2 hydrogens. So in order to balance the hydrogen, we need to multiply 6. Okay, that will give us a balanced chemical equation. Okay, next question. So what would be the formula of the precipitate that forms when the lead nitrate and potassium sulfate are mixed? So lead nitrate and potassium sulfate. Okay, what will be the precipitate? Again, based on what we learned yesterday, we just need to swap the cation and anion. Okay, so this will lead to one potential product, which is a lead sulfate. Another one is we combine this potassium and nitrate will give us a potassium nitrate. Okay, so among these two compound, which is the precipitate or which does not dissolve in water? We need to go to our like the solubility chart and figure it out. So let's first check the lead sulfate. Okay, it contains the lead. Which one? Here, one compound contains SO. The sulfate will further check whether it contains a calcium, strontium, barium, or lead. Okay, it does contain the lead, which means this is insoluble, which means this will be precipitated out. Okay, will be precipitated out from the system. Okay, so the formula for the precipitation will be the lead sulfate. Next question, which of the following compound is soluble? It's soluble. Okay. If we try to observe these four compounds, they all contain aluminum, right? They all contain aluminum. So, or we can do another way. Let's check the first one, aluminum hydroxide. Aluminum hydroxide contains OH, and then we'll further check whether it contains the lithium or contains sodium, potassium, or like ammonium. No, it doesn't. And then we'll further check whether it contains the the calcium, strontium, or barium. No. Okay. So means this one is not soluble. So which means aluminum hydroxide is not soluble. Next one, aluminum sulfate. Aluminum sulfate is something we check here. If it contains aluminum, if it does not contain this following compound, it is soluble. Okay, so the aluminum sulfate is soluble. Next one, aluminum carbonate. Aluminum carbonate, we should go to here, right? Right? Compound contains the carbonate. Okay, it contains the carbonate, and we will further check whether it contains this following ions. Apparently, aluminum does not belong to this group, so it reached to insoluble. So aluminum carbonate is insoluble. The last one, you can apply the same strategy, and the diagram will tell you the aluminum sulfide is also insoluble. Okay. Next question. All of the following compounds are soluble in water except. So basically, this is the same. We are just applying the same strategy to try to solve this question yourself by reading this diagram. Okay. The last question of this question review slide. Which is the spectator ion from the following complete ionic equation? So we need to understand what does the spectator ion mean. Spectator ion means the ion that appear on both left side and on the right side. It means this ions does not really participate in the reaction. Okay, so now let's see which item. Bromine, Br minus. Br minus on the left side and on the right side. So Br minus is definitely a spectator ion. The next one will be the potassium because potassium on the left side and on the right side. So for this question, the correct answer should be the bromium and the potassium ion. Okay, so that is for this question review slides. I hope it is helpful for you to get prepared for this week's quiz. Thank you so much for your attention, and bye-bye.